Hello everyone, welcome back. Today we're going to look at the last section in this chapter, which is on forces in equilibrium. So let's start. When there is no acceleration, according to Newton's first law, there are two cases. First one, the object must remain at rest, or the object could continue to move with a constant velocity. In those cases, we say that the object is in equilibrium. If an object is in equilibrium, then the resultant force is zero. So what does that mean? So if you think about the Newton's second law formula, F equals ma, and we know that there's no acceleration, so that means F equals zero. When we substitute into the formula, F would equal to m times by zero, which equals zero. Hence, the resultant force F will be zero. So let's look at some examples. So assume all the objects we're going to look at are in equilibrium, which means the resultant force has to be zero. Okay, let's have a look at this first object. We have two forces acting on the object in a vertical direction. One, let's say it's a tension, which is 20 Newton, and we have another force X acting downward. If the object is in equilibrium, then the resultant force has to be zero. So that means X will have the 20 Newton as well to balance with the 20 Newton pulling upwards. Okay, let's have a look at the second example. So again, we can straight away see in the vertical directions there are two forces, X going up and 50 Newton going downwards, and they have to balance with each other. That means X has equal to 50 Newton. Now, let's look at the horizontal forces separately. So again, because we're not moving in the sideways direction, so Y has to balance with the 35 Newton. So Y must be 35 as well. If you look at the next one, here we have two forces, 20 Newton and 30 Newton, pulling towards the right-hand side, but we have a single force X acting towards the left-hand side. Again, if it's in equilibrium, then all those three forces has balance. That means X will have equals to 20 add to 30. So X will come out to be 50 Newton. So then the overall resultant force would add up to be zero, because we have 50 Newton plus, let's say, a negative 50 over here. Okay, so in this fourth object, let's have a look in the horizontal direction. And we can see straight away that Y has to equal to 88 Newton. And here we have 100 Newton pulling upwards, and we have X and 6 Newton pulling downwards. So those three forces has to balance, giving resultant force of zero. It means X must be 40. Okay, now let's have a look at the next here. All right, so then in this case here, we can see we have 35 Newton. Now be careful here. The arrow is actually pointing downwards, which means it could be a thrust, so it's pushing down. And 25 Newton is acting downwards as well. So really, the overall, the total downward force would be 35 plus 25. And that has balance with the force acting upwards, which is X. So in this case, which is different to the other question we've done, X actually equals to 35 plus 25. And that come out to be 60 Newton. Okay. Oops. What happened to my? Sorry about that. Let's try again. 60 Newton. Okay, so the arrow is very important here. Right, have a look at this one. So what do we have? So we have y is actually pushing the object towards the right hand side. So you can make the arrow a bit bigger, you can see. And we have another two arrows pointing towards the right hand side, which is 15 and 45. So what that tells me is that the forces acting on the right hand side must add up to the forces acting towards the left hand side. So the resulting force is 0. So that means we have 98 equals to, in this case we have y plus 15 and then plus 45. So we'll get 98 equals to y plus 60. So y must be 38 Newton. Great. So after we look at a simple example, let's put into context. So let's move on to our first worded problem. Okay, in this example, we have a large box of mass 80 kg hangs in equilibrium supported by 4 cables as shown in the diagram. The tension in each cable has magnitude T and the value of T. So let's start to label all the forces in the diagram. So for each cable, there is a tension of T. So let's label T, 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 and T. And now this box also has a weight, as we talked about in the previous section. So weight W will equal to M times by G. And we already been given the mass is 80. So that would be 80 times by G, in this case, again, we're just going to use 9.8. Okay, so now if it's equilibrium, that means all those 4 tensions must balance with the force acting downwards. So the resulting force will come out to be 0. So we can then say T plus T plus T plus T. Why don't we say that's just 4T? Plus equals to W. Or you could also write down 4T minus W equals 0. They mean the same thing. Okay, so now we have 4T equals to 80 times by 9.8. So T would equal to 80 times 9.8 and then divided by 4. So the final answer is 196 Newton. Great. Let's have a look at the next example. So if forces are acting in 2 dimensions, both horizontal and vertical components need to be 0. Okay, so just like those, you remember those 6 simple questions we looked at before, just like that, we have to treat horizontal and vertical direction differently. But again, they should always add up to 0. So here we go. A particle is in equilibrium under the action of 3 forces, F1, F2, and F3. Find the values of X and Y. So as we know, all these 3 forces should add up to be 0 because the particle is in equilibrium. So now we can write down F1 plus F2 plus F3 equals to 0. And now let's use that column vector. So F1 is 40, 2x. F2 is y minus 32 plus F3, and that is x, y. Equal to 0, again, that's in vector form, so it's 0, 0. So let's consider, so if you look at the top line, that would be the forces in the horizontal direction. and the second line would be the forces in the vertical direction. So now we have 40 plus y plus x equals to 0. And the second line we have 2x minus 32 plus y equals to 0. So all we need to do is to solve these simultaneous equations and work out the value of x and y. So it's up to you which method you like to use, but what I could do is simply just let the top equation equals to the second one, because they both equal to 0. And we can see straight away that the y and y will cancel out. So let's do that. So we have 40 plus y plus x, which is 0, and also 0 equals to 2x minus 32 plus y. Okay, so as I said before, the y and y cancels out, and we end up with 40 plus x equals 2x minus 32. So why don't we put all the numbers to the left-hand side and the letter x to the right-hand side? So that would become 40 plus 32, so that's 72, and 2x minus x, so x cannot be 72. Now, when I know that x cannot be 32, we can substitute back into one of the equations. Let's do the first one, because that looks the easiest one, to work out the y value. So we now have 40 plus y plus 72 equals to 0. So we now know that y must equals to negative 112. Okay, so here are my answers for x and for y. All right, perfect. Let's look at the next example, which is our final example. So a box of mass 60 kg has an equilibrium supported by 5 light inaccessible cables as shown in the diagram. The tension in the 2 vertical cables are T and 2 Newton, as you can see from the diagram, and the tension in the horizontal cables are 106 Newton, 50 Newtons, and P Newton. Find the values of P and P. Now, I can see that the diagram is quite small, so if you struggle to read numbers on the diagram, please refer back to the PDF document I sent to you and your email. Okay, so again, we talked about how we have to treat this in 2 different dimensions. So why don't we start to consider what's happening in the horizontal direction, and then also what's happening in the vertical direction. Okay, so let's see. In the horizontal direction, we have 3 forces. So we have 160 Newton, P Newton, and 50 Newton. Okay, so let's say the object, well, let's assume that this is a positive direction, but also we know it's in equilibrium. So the resultant force must add up to be 0. So what we have here is that P plus 50 must equal to 160. So straight away we know that P equals to 110. All right, now let's consider in the vertical direction. We have again 3 forces. We have T and 2T balanced with 60 G Newton. So then we have T plus 2T equals to 60 G, and G is 9.8. So basically that means 3T equals to 60 times by 9.8. You could put in your calculator and work out T can be 196. Okay, So this is the end of this section, and in fact, this is the end of this chapter on force and motion. What I'd like to do now is to have a look at the questions in exercise 21E, and could you try those questions and use the knowledge we've learned about equilibrium to work out the missing force, please. So here we go. This is question 1. And here is question 2. Question 3. Question 4, 5, and 6. Question, too quick. Question 7 and 8. Question 9 and 10. And at last, question 11 and question 12. And here are the answers for exercise 21